Hello, everyone. My name is Kevin McCabe with the National Renewable Energy Laboratory. Welcome to today's webinar, hosted by the Carbon Capture, Utilization, and Storage, or CCUS initiative, an initiative of the Clean Energy Ministerial. Today's event is brought to you by representatives from the cement sector, and we're especially excited for this event as we are also joined today by our partners with the Global Cement and Concrete Association, or GCCA. There's a lot to cover, so let's quickly go through some of the nuts and bolts of the event today. If you can hear the sound of my voice, congratulations, you've successfully connected to the audio. However, if you encounter technical difficulties at any time during the webinar, you may contact the GoToWebinar's help desk at the number shown on the screen. That is 888-259-3826. And they should be able to provide most types of audio video support. Okay, hopefully you're seeing the slides now. My apologies. If you would like to ask a question, we ask that you use the questions pane of the GoToWebinar platform, where you may type it in at any time during the webinar. Shortly following the conclusion of the event, the recording will be added to YouTube, and the presentation slides will be uploaded to the Clean Energy Solutions Center site, links for which can be found here. A kind reminder to our audience that the recordings from previous webinars held by the CCUS initiative are hosted in a dedicated YouTube playlist. Follow the link on this slide. Again, slides will be posted following the conclusion of the event, or perhaps easiest, simply search for our Clean Energy Solutions Center on YouTube and click on the playlist tab. The CEM CCUS video playlist can be found there. Before we begin the presentations, I'll provide a quick introduction of today's panelists, followed by some brief welcoming statements from both Jared Daniels of the CEM CCUS initiative in the U.S. Department of Energy and Claude Lorea of the Global Cement and Concrete Association, both of whom will provide some context for today's webinar. Then, following the panelist presentations, Jared and Claude will moderate the panel discussion and Q&A session, where the panelists will address questions submitted by the audience and engage in a broader discussion of the topics at hand. Our first speaker today will be Jared Daniels, who leads the Office of Strategic Planning, Analysis, and Engagement within the United States Department of Energy, Office of Fossil Energy. Following Jared will be Claude Lorea, Cement Director for the Global Cement and Concrete Association. After Claude will be Jamie Gentoso, Chief Executive Officer for the U.S. Cement Organization of LafargeHolcim. Following Jamie, we'll hear from Rob Vandermeer, Director of EU Public Affairs at Heidelberg Cement. And finally, we will hear from Tongbo Sui, Vice President of Sonoma International and Director General of the Sonoma Research Institute. And with those brief introductions, I would now like to welcome Jared to the webinar. Jared.
Well, thank you very much, Kevin, as usual, for the introduction and for hosting our event today. I'd like to start our conversation by briefly describing the Clean Energy Ministerial and our CEM CCUS initiative and why we feel that CCUS in the cement industry is so critical. The Clean Energy Ministerial, or CEM, is a partnership of the world's key economies working together to accelerate the global clean energy transition. The 26 member countries plus the European Commission as CEM members represent 90% of clean energy investments globally and 75% of global CO2 emissions. Several years ago, we started the CEM CCUS initiative based on the premise that if all of the models and analysis show that CCUS is an absolutely critical technology to enable us to meet our mid-century climate mitigation targets, then CCUS should be part of the broader clean energy ministerial discussion and body of collaborative efforts. Our CCUS initiative now has 11 members. You can see the flags represented on the slide, and the lead countries are Norway, Saudi Arabia, the United States, and the United Kingdom. Next slide, please. We tried to accelerate CCUS under our CEM initiative by just several high-level methods. First, to actively include CCUS in the broader energy and climate mitigation conversation, specifically under the CEM. We also work to bring governments and the private sector and the investment or financial community together to focus conversations on how we can get and speed deployment of CCUS, such as what we're doing here today. We also facilitate conversations identifying near and long-term investment opportunities, again, for promising CCUS deployments. And finally, we try to disseminate best practices in CCUS policy, regulation, and investment. On the next slide, this states that, much is changing in a positive manner in the energy and climate change mitigation conversation and policy, and for CCUS in specific. There are a number of countries now with net zero ambitions by 2050, and that number is growing almost every day. There's also a number of countries that have specific policies to support and advance carbon capture, utilization, and storage as part of that broader effort. For example, here in the United States, where I live and work, we have 45Q tax credits that are meant as a federal policy tool to accelerate CCUS deployment. And you can see on the slide there are other countries that have CCUS specific enabling policies as well. Currently, there's on the order of 20 commercial projects, CCUS integrated full-scale projects operating around the globe today. And in the recent years, there are many new projects that have been announced, some 30 new projects in the last several years, in fact. But again, collaboration remains critical, and bringing together governments at national and subnational levels and industry that will actually build, own, and operate the carbon capture, utilization, and storage equipment and processes, and the finance sector to allow finance to flow and to allow positive financial investment decisions to be made for new projects. This type of collaboration remains critical. And finally, we're at a point where resetting the strategic narrative broadly is perhaps an appropriate use of our time and effort to state the fact explicitly that carbon capture, utilization, and storage is a technology that spans well beyond the power sector. Indeed, it is one of the key technologies to enable deep decarbonization in hard-to-abate industry sectors where there simply is no other technology choice for deep decarbonization. CCUS can also support carbon removal or net negative schemes where you can actually pull CO2 from the atmosphere if as a society we need to go there. And so on my last slide, again, it brings us to our topic of conversation today, the fact that CCUS is a critical solution across many sectors in industry, specifically in heavy industry, where a large part of the CO2 emissions are actually process emissions from those industrial processes themselves. And just to put a framing order of magnitude on it, in 2019, those process emissions were 2.5 gigatons globally, which is equivalent to India's total annual emissions. So this is quite a large slice and becomes a larger percentage as we decarbonize other aspects of society. And 63% of those were from the cement sector. So hopefully with this brief framing, you can see that CCUS is a central solution and is of great concern, specifically in the cement sector. And with this is brief introduction and framing of the CEM and our CCUS efforts broadly, I'll now ask Claude to tell us about the Global Cement and Concrete Association's efforts and ambitions regarding carbon capture and storage. Claude, over to you.
Thank you, Jared. Hi, everyone. So yes, the GCCA is the Global Cement and Concrete Association. We are a CEO-led organization, and we have around 40 members, and we represent a little bit more than 40% of the world capacity, trying to increase that number. We are rather a young organization. We have been established in 2018. And I would really like to frame this webinar into our climate ambition. So last September, the GCCA has released a climate ambition whereby our members commit to continue to drive down the CO2 footprint of their operation and their products, and aspire to deliver a society with carbon neutral concrete by 2050. And to do this, we will work across the built environment value chain to deliver this aspiration, and this in a circular economy and wildlife context. If we can go on to the next slide, Kevin, please. Now, why is this so important? And actually also probably why is this webinar so important? Concrete has an essential role to play in the modern world. We know that we have an increasing population, increased urbanization, still the need for housing, but but also concrete has an essential role to play in delivering clean energy by building hydropower, windmills, schools, hospitals, as I said, housing, safe dwellings. But last but not least, we also need to build more resilient cities to protect our cities and the people from changing natural environment and changing climate. Concrete also has an essential role to play in providing clean water and sanitation. And I could speak, I think, for the whole webinar about the benefits of concrete, but that's not the point today. So please go on the next slide. And we have a certain number of levers to achieve carbon neutral concrete. And also, as I said, we want to do this from a whole value chain perspective. So we have the levers that we know. It's to increase fuel substitution, to have more energy efficient processes, to reduce the clinker or the binder content in cement and in concrete, to reprocess, to be more circular, also over the whole value chain, to recycle aggregates, turn construction and demolition waste into recycled aggregates. Also quantify the level of CO2 uptake by the built environment, but essential will also be to reduce process emission through new technologies. And this is actually what we call carbon capture, use and storage. And that's, we will hear more about 3 of our members actually today. So if we move on to the next slide, to finish my introduction, this climate ambition is also accompanied by a set of policy asks. So what do we need from policymakers? And I would really like to draw your attention here on, amongst this, first, the need to support research and development of breakthrough technologies, as well the acceleration and proven efficient low carbon technologies with a specific focus on CCUS, and then also promote cooperation between governments to develop the CO2 transport and storage infrastructure that is needed. And last but not least, also had to drive the demand for sustainable building materials. So those are the policy asks that we have, and I think that my last slide, Kevin, and we can go immediately into our speakers that will share more on the field presentations. Thank you very much for being with us today.
Great, thank you, Claude. And yeah, indeed, let's dive right in to hear some more about the industry perspective. So Jamie, welcome to the webinar.
Thank you. And thank you for the opportunity to share a little bit about LafargeHolcim and the role that CCUS plays in our organization. LafargeHolcim is a global leader in cement and concrete. We operate in 75 countries across the world, and we have about 2,300 operating sites. As a leader, we believe it is our responsibility to help lead the way to a net zero future. And as such, we've made a net zero pledge. And to get there, we've created a path starting with our 2030 targets that have been validated by SBTi. We currently spend about half of our R&D efforts toward the development of more sustainable, low carbon products. And we've been successful such that nearly 1/3 of our sales come from lower carbon solutions. Next slide, please. And this is a path that we didn't just start yesterday. So over the last 30 years, LafargeHolcim has been successful in lowering our carbon intensity by 30% through upgrading our facilities, using alternative fuels, and clinker factor reduction. And our targets have us reducing by another 15% by 2030. Next slide, please. And the work we've done is important. As it's already been mentioned, concrete is a very important product to society. It's not going away. It is the second most consumed product in the world next to water, and demand will continue to grow. And even in its existing state, and it remains the most durable product with the most longevity, it has resiliency, and all with that combined, and even with its impact, it still has the lowest embodied energy and lowest carbon intensity versus other building materials. So we really have to decouple the material impact of concrete from the volume demand of concrete and understand that despite its impact, it still is the best building material. But that said, we realize that every ton emitted still counts, and that we must work tirelessly with both short-term goals and long-term reduction targets. Next slide, please. So there's work we can even do in the short term, and many of the levers that we have were already mentioned, but we have barriers to some of these levers. So clinker factor reduction is something that we work on, but acceptance of these lower carbon products that this creates is an issue, especially here in the United States. Our clinker factor is currently 90%, and we're working to drive that down. Alternative fuels, we also have barriers there, getting local regulators to approve that, but also use of unconstrained natural gas is an issue for us. We're working to increase our use of renewable energy. Currently in the US here, I have 6 different projects going to increase the use of solar as well as the use of wind to power our plants. We also continue to try to improve the efficiency of our plants. So we've invested over the last 10 years here in the US alone, almost $1 billion just to upgrade our facilities. But we have work we can do to continue to use the data that we collect in our facilities to increase their efficiency and use AI to automate things. And then I mentioned before, the use of green products, really important that we get acceptance of green products and get our regulators and those who actually procure the most green products to get them utilized. And then finally, carbon capture. We understand that carbon capture is going to play a fundamental role, or will play a fundamental role, in getting us to net zero. Next slide. So within CCUS, we are working in all 3 fields, capturing, utilization, and storage. And across the world, we have 20 different projects that are in all different stages. So this large range of CCUS projects give us the flexibility in applying these technologies, and hopefully in the future, we hope that we'll have both the best technology and the cost that we can replicate across the entire world. We know that there's no single solution. It's going to be difficult to scale in some places. Different local partners will have different local regulatory frameworks, and we'll also have different geological conditions. So we need to explore all different possibilities. But also, as we do this, the one other key question is, what do we do with the CO2 afterward? So we look at utilization. We need to be able to take this pollutant and use it as a raw material for various products. So building materials is one. We're definitely exploring that, looking at mineralization, creating aggregates and such. Also utilizing CO2 to cure concrete. We have a product called Solidia that allows us to use almost 1/3 a ton of CO2 to cure a ton of concrete. So high utilization of CO2 there. But we're also looking at the use of it as synthetic fuels, renewable plastics, uses in greenhouses for growing crops. So we're looking beyond just the cement in the building industry and other materials to find solutions for the use of CO2. And on the other hand, we continue to investigate CO2 sequestration. We believe this will also be an important part of the decarbonization journey. Next slide, please. And we know we can't do this alone. We're clearly ready and willing to play a leading role in the industry, but there is both a need and an opportunity for cross-industry collaboration. And just as we're experiencing right now on our project in Portland, Colorado, there's really a need for different sectors to come together to bring their skills and collaborate. So we need the oil and gas, the chemical and the power industry to really come together to integrate on project development. We also know that we need public support. So it's important that we take the lead and educate in both utilization possibilities as well as storage possibilities. And we also think that CO2 infrastructure is a key. Transport and storage hubs can really provide an opportunity for multiple industries to come together and create economies of scale so that they can dilute project risks. And finally, we really think that support of the government and regulators play one of the most important roles in this. Next slide, please. So policy must support CCUS. It's clear that investment and research is continually needed. We need CO2 capture in both scale and to happen economically. Innovation for the use of captured CO2 must continue. So we must continue to find ways to use the CO2 once it is captured. I mentioned the CO2 transport and infrastructure, but we also believe that a price on carbon can be an effective way to stimulate reduction efforts. but we think it must be effective. It must really focus on reduction outcomes. It must be market-based. We believe it should be economy-wide. So as we look across the United States here, we think carbon policy should be a federal policy versus an individual state policies. It must be durable and responsive, so it must adapt over time. It must do no harm. We want to remain competitive within the economy, and it must promote equity. It needs to distribute the costs and the benefits across communities, and most importantly, in disadvantaged communities. Next slide, please. And in the end, you know, Lafarge Holcim, we are committed to a net zero future. We believe that CCUS is a part of that, so much so that we have committed that as part of our 2030 targets, that we will operate our first net zero production facility. Thank you.
Great, thank you, Jamie. We'll now hear from Rob Vandermeer with Heidelberg Cement. Rob, welcome to the webinar.
Yeah, thank you. And thank you for the invitation to participate in this call, in this webinar with extreme amount of participants. That is really very good news, and you see the interest in the topic for the cement industry. Please, can we skip to the next slide? What is for Heidelberg Cement the goal? Our goal is to realize carbon neutral concrete by 2050 at the latest. In some countries, we will be faster. In some other countries, we will be a little bit slower. But overall, our 2050 target is clear, and we have put it in publications. We have put it also now very dedicated for all plants operating in the group with targets and with emission reduction trajectories over the next 30 years. A huge task is lying ahead of us. So when I go to the next slide, and you also saw that slide, but in a different format, different way of presenting, of course, in the presentation of Jamie, you'll see what we have to do and where the measures are. The first step is the traditional or conventional measure to reduce carbon emissions from cement production. That is we are talking about clinker substitution, we are talking about new fuels, but also about new types of products, low carbon products with less clinker, perhaps other types of clinker, with other types of binder and other types of cementitious materials. All that is going on, and for that I can say that about 80% of our R&D budget is going into that type of measures all over the world, and that will not stop. The second one is about circular economy and innovative products, and especially real low carbon cement, complete new types of products that will come into the market. You see some developments in this already. The third element is about carbon capture and use of CO2, plus the electrification of kilns. We have done our first project in Sweden together with Vattenfall, looking at the possibilities to electrify a cement kiln. Not easy. We are talking about plasma technologies, so it is not ready for implementation, but the way forward is there. Nevertheless, we have to keep in mind electrification or also hydrogen-fired kilns will not reduce the emissions from processes, so the carbonation emissions of the cement production. So that is still an issue that we will have to take care of. And for that, carbon capture and storage, and also carbon capture and use, is important. I will come back on that. The last point in this slide is the natural recarbonation of concrete by CO2. That is a normal process, not very well understood, not necessarily recognized by all stakeholders, but it's happening. And that can be triggered. We can enhance that natural recarbonation, which helps us to reduce the emissions of global climate change gases in the world. Here you see the picture for 2050, but we are now in 2021 since a few days. So let's go to what are we doing? The next slide. And I want to brief you on the three challenges that we see in this road to carbon neutrality. The first one is to look at capture, energy efficient capture of CO2 from the kilns in our production processes. And for that, we have more types of technologies available, but I listed here 3 of them. The first is the post-combustion process, in which amines are absorbing CO2, and that CO2 can be desorbed, stripped in a separate insulation, and can be used for, say, carbon capture and storage, but also for use in installations. We have several projects in Europe running, 4 research projects mentioned here, and I want to highlight 2 special products. The first one is the pre-industrial project in Edmonton, Canada. That's one of my last slides, so I will come back on that. The second one is, in fact, the first industrial commercial scale project that is going to happen in Brevik. At the end of last year, we got the final approval by the Parliament in Norway for this project, where we will capture 400,000 tons of CO2 a year and store it in the North Sea underground. That is a big step for cement industry worldwide. It is also a big step, of course, for us. We have been working on this project since 2005, and it will be in operation in 2024. So nearly 20 years of development, research, and all that. The second type of technology that we are looking for, which is not ready yet for implementation, is oxyfuel, in which oxygen is used for combustion processes. Early stage projects have been done together with ECHA, European Cement Research Academy, but also University of Mons in Belgium. And one of the first projects that we are running together with partners is Catch for Climate in Germany, where we will have a pilot scale, in fact it's rather bigger than a pilot scale, installation in southern Germany, where we will capture the CO2 and use it for different purposes. The third technology that I wanted to highlight is the direct separation methodology that has been developed in the LILAC project in Belgium, in one of our plants, and now we are going to the second phase of that project, a pre-industrial scale installation in Hanover in Germany. This is a complete different type of technology for cement industry. It's new, it's really a breakthrough technology. It is pre-industrial scale, so we really have a lot of opportunities, but also a lot of challenges. But it's an interesting technology because it's different to the traditional technologies as mentioned in the post-combustion and the oxyfuel. In fact, all 3 are very interesting, and as chemical engineer, I'm delighted to see this happening. The next slide is on the second challenge that I wanted to highlight. The second challenge, and please next slide, because then you can see what I wanted to show here. The second challenge is about how can we use the CO2. I'm not sure that this is running well. Can we go to the next slide? Yeah, and the next slide, last one for this. Yeah, and the next one, indeed, sorry. You see here the different purposes and the different possibilities for using CO2. The first one is Catch for Climate in, well, I mentioned already in southern Germany, where we will look at how can we use that CO2 for producing fuels, like also the projects of LafargeHolcim. The second one is looking at the possibility in the left corner, is looking at the possibility to use the CO2 for recarbonation, but also for mineralization of aggregates, a complete new topic for industry, but very important for the concrete industry. Number 3 is about the use of algae, so CO2 to produce algae. We have a huge project in Morocco, in Northern Africa. And the last one is combination of these technologies in one different bigger product where we can use also the CO2, for instance, for food and beer production. I would like to go to the third challenge. And that's the next slide here. The third challenge is about carbon capture and storage. Offshore storage, very well known, especially in Norway, the Norwegian project I mentioned already, but also in the UK and also in the Netherlands, work is being done on offshore storage. On the other hand, we think that in Eastern Europe and Southern Europe, offshore storage, so in the sea, is much more challenging because there is not much storage capacity. And we see possibilities in onshore storage, so on land. And we are developing, in fact, 2 projects in Eastern Europe at the moment. We were just not ready for application for the first round of the EU ETS Innovation Fund, but that is for the second round possible. I would like to go to the next slide, because there I promised to say something about, this is super fast. There was a slide about the Edmonton project. The Edmonton project is a project in Canada. I wanted to show that because that is an amine absorption unit that we want to install there, and where we want to connect directly our plant for CO2 delivery to the trunk pipeline for CO2 in Canada. And that CO2 will be used for enhanced oil recovery. So an interesting, different approach. It's a different approach to the traditional carbon capture and storage facilities. It's about enhanced oil recovery, so it has some added values. On the other hand, it is challenging. Nice thing is that the pipeline is quite close to our plant, so it's easy to do, and the technology is available. Last thing then that I wanted to show here and to talk about a little bit is what are the fundamentals for decarbonization of the industry. The first one is the technical requirements, and I've highlighted in this presentation that there are a lot of developments, and that these developments are very positive. The second one is the infrastructure that is needed for this. We need a CO2 infrastructure and a hydrogen infrastructure and renewable electricity. We need recycled concrete to be used in concrete in the future. That is a challenging thing. The Canada project is for us very interesting because there is already infrastructure in the neighborhood, but in many places there is nothing. And especially in Africa and Asia, that will be a huge challenge, apart from already huge things to be done in US, Canada, and Europe. The last one, and I think that is a fundamental request that we have on this, is how do we get economical feasible solutions for the industry? And with that, I wanted to close. We see CCS, next slide, last slide, we see CCUS as a key pillar for carbon neutrality in 2050. Not the only one, but it's a fundamental one. And the slide, the picture that you see here is the Brevik plant in Norway, where we will have that first industrial scale CCS application in the cement industry. Thank you a lot.
Great, thank you very much, Rob. Next up, our final panelist will be Tongbo Sui of Sinoma International. Tongbo, welcome.
Thank you, dear colleagues. Good morning and good afternoon. My name is Sui Tongbo from Sinoma International CMBM. Very honored to be invited to attend this important webinar discussing the critical solution in the future, to address the carbon neutrality 2050. Today, I'm going to share with you the CCUS and China cement industry. So next slide, please. But before I get into the main track, just a few words about Sinoma, which is a world-leading cement engineering company providing complete chain sustainable solutions to the cement industry. These solutions include the enhanced clinker replacement, the continuous energy efficiency improvement, the co-processing of the municipal solid waste, hazardous waste with cement kilns, the waste heat recoveries for the power generation. Recently, the intensive effort have been made by using the AI to upgrade the existing cement facilities and also the CCUS. That's the topic today. My presentation will cover in 2 parts. So next, please. So in the first part, next, the 4 CCUS technical solutions relevant to cement sector will be introduced. Next, please. So the first solution we have in China is a CCUS cement via calcium looping. The demonstration project, the result was published in the Energy Procedure 2014. It was conducted by Taiwan Cement Corporation and technically supported by the ITRI. So the CO2 capture rate of this pilot project is more than 110 per hour, and the CO2 capture efficiency is higher than 85%. So next, please. The second solution is the CCUS cement demonstration project with the post-combustion. This project is carried out by the Anhui Conch Cement in October 2018 with technical support of Dalian Polytechnic University. The trial production was built in connection with the clinker facilities with capacity of 4,500 tons per day, the clinker. The trial production was built in, and the design capacity of CCS is 50,000 tons of CO2 per year, making two types of CO2 products, industrial scale and the full scale. And to the right, we can see the flow chart of the CO2 capture and purification system by Anhui Conch Cement. So next, please. The picture shows the CCUS facilities in the cement plant. Next, please. The third solution is the CCUS cement with mineralization sequestration process. The demonstration project designed by Sinoma. The concept is to use CO2 from the flue gas to react with the carbide sludge, mainly containing calcium hydroxide, to produce the high value added precipitated calcium carbonate. By using the same solution, precipitated barium carbonate can also be produced in the industrial projects in China. Next, please. Another example of the CCUS cement via mineralization sequestration process is the demonstration projects with technical support of Zhejiang University. 72 hours trial was made to produce the pavers while CO2 curing instead of autoclave curing. They use steel slag, bottom ash, etc. as the main raw materials to produce the concrete pavers, about 1,800 tons. And the efficiency for CO2 sequestrated by the pavers is more than 80%. So next, please. The fourth solution is the CCUS cement via oxy-fuel and CO2 enrichment process developed by Sinoma in China. By using this process, the CO2 concentration can be increased. The normal concentration of CO2 20% up to 75%. So with the enrichment of the CO2, we expect the CAPEX and OPEX cost for the CCUS can be reduced by 10% and 30% respectively. Next, please. The flow chart indicates the pilot project designed by Sinoma with CO2 capture capacity of 50,000 tons per year. Next, please. Now comes the second part, the policy and future perspective. Next, please. So far, by the end of 2019, the demonstration CCS projects happened in China. So 9 for CCS and 12 for geosequestration and utilization. So far, 2 million tons of CO2 have been sequestered by this in these projects. And the projects mostly happen in the coastal and the power sector. The pilot ETS process in cement sector has been implemented since the year 2011, mostly in the 7 provinces and municipalities. At present, the following challenges on CCUS cement have been addressed, which include the further R&D to reduce the cost. The policy regulation standardization enhancement, financing and business model, cross-sector and international collaboration. Next, please. Thanks to the government continued support to to the control of GHG emission and CCUS. So a number of the policies, regulations have been enforced since the year 2006. Some of them are listed here, but why the most important certainly is the commitment made by our President Xi Jinping last September at the 75th session of the United Nations General Assembly. We aim to have CO2 emission peak before 2030 and achieve carbon neutrality before 2060. Now the whole country is taking action. Next, please. I look forward to working with you for a community with a shared future for the mankind. Thank you very much.
Wonderful. Thank you to all the panelists for those outstanding presentations. As we shift to the Q&A, I'd like to remind our attendees to please submit questions using the question pane at any time. I'd also like to invite, here we are, all the panelists to re-enable their webcams, and we'll have Jared and Claude lead the discussion. Take it away.
Excellent. Well, thank you, Kevin. Thank you to our panelists for your opening thoughts. I think Claude is going to ask the first question. We've got a couple of questions that have come in that are specific to some of our presenters, and I think we've got a couple of topics that are sort of general questions on cost and infrastructure that perhaps we can get to as a panel and hear all of your perspectives. But Claude, why don't you start us off?
Yeah, I'm happy to start off, and maybe I will start off with a specific question to the last speaker. Thank you very much, Tongbo, for having shown us, what's happening in China. We are all very interested to hear about that, and we know that China is a big part of the cement industry related emissions. How long would you say, Tongbo, it will be before the first large scale carbon capture plant in China?
The first project, as I introduced in the slides, was the demonstration project in 2014, actually made by Taiwan Cement Corporation. This so far we can say actually 6 years passed, since the pilot project started. So now and later we have Anhui Kanch as also indicated, 2 years back, and Sinoma now actually also developed another solution to use oxy-fuel, technology combined with the CO2 enrichment and the future and the later physical adsorption. So with the solution, we expect the cost for initial investment and as well as the operation cost can be reduced. Thank you, Claude.
Thank you, Tongbo. Thank you.
Yep, and so maybe I'll tag. Sure,
Yeah.
I'll tag in here. And, there was one question that came in early in terms of someone had thought that CCUS had a near-term role, not a long-term role. And I think most of the global analysis suggests a growing role for CCUS well into the out years, especially if you believe we'll need to develop net negative carbon technologies to meet our global goals. And so, what we've been talking about here in the cement and concrete industry, I think, is expected to grow in terms of opportunity and requirement for CCUS to decarbonize as we decarbonize other aspects of society, whether it's more renewable in the power sector, or whether it's decarbonizing, transport or better insulation and efficiency in our homes. These hard to abate process emissions become a larger and larger percentage of the remaining emissions in decades to come, and hence CCS, all technical analysis suggests this will be a growing part of that solution set globally, essentially toward the back half of this century. So hopefully that adds to the framing. There were a couple of questions on the costs that we're talking about here. And Jamie, a question came in specifically addressed to you in terms of, in the United States context, is 45Q enough as an incentive, or do we need other policy mechanisms and support? Perhaps we could ask Jamie to answer that question from her perspective in the US, and then we could ask our panelists just to opine on the broader topic of the cost. What will this add to the costs, and what are your thoughts on how we deal as a business across that entire value chain with the cost to decarbonize concrete and cement? So Jamie, over to you with the US context.
Sure, I'd love to make a comment also regarding CCUS being near-term or long-term solution. I think we have aspirations and hopes that we could see something happening within the next 5 years. So our project right now in Portland, Colorado. Right now we are, thanks to the DOE, we are continuing that project. We've been given a $1.5 million grant in order to continue the FEED study there. So the hope is that that project that will capture 2 million tons of CO2 per year will be shovel ready by 2023. So to me, that means operating by somewhere in 2025, 2026, which again would mean we're capturing CO2 on a large scale. Now, when it comes to cost, the 45Q definitely helps. And that helps with the operating costs and such. So, around $35 for use in for EOR and that kind of thing. And then if you're looking to geologic storage, $50 per ton. So that helps with the operating costs. But part of the bigger issue is the upfront cost of building the facility. So what we're looking at right now in initial estimates to build the carbon capture unit is somewhere around $350 million. So big investment. So really, I think this one is the first step to say we can capture and scale, but we need to be able to do it economically. And of course, like I mentioned, the 45Q helps from the operating perspective. But in the end, we also need to find more economical solutions in order to decrease the cost overall.
Great. Thank you, Jamie. Maybe, Rob, we could turn to you for your thoughts on costs and opportunities.
Costs and opportunities was in fact my last point. We have to make it economical feasible to have carbon capture or to have decarbonation of industry happening. That's the important step. So the subsidies, EU45 in the US or the EU ETS innovation funds are absolutely needed to trigger the kickoff of this implementation of technologies. But looking at the innovation fund in the Europe, that is only 60% of costs for the 10 years. Covered in such a way, and that is at this moment simply not enough. That is the challenge that I see. Projects coming on stream, I see at least within our company 3 projects in the next 5 years coming on stream, really implemented. That is the Norcem project, that is the Edmonton project, and that is what I've mentioned, the actual climate project in Germany. And personally, I expect 2 other projects in Eastern Europe coming very soon, perhaps in less than 5 years or a little bit more than 5 years. The fundamental thing, and now about costs again, the fundamental thing is that cement and also clinker is an intermediate product. So we have to keep in mind that most people are not buying real cement, they are buying concrete. And when you put the cost of decarbonation of the industry, of the cement industry, you change the perspective, not the value of course, but the perspective from cement to concrete, we are not talking about huge changes in cost price of concrete per cubic meter of concrete. It's rather small. When you talk about cement, the cost could increase to, say, 2 times as much as today. So carbon cost in cement, yes, doubling perhaps, huge, a real challenge for cement industry. Carbon cost on concrete, smaller. Carbon cost for a, say, single family house made out of concrete, to be honest, that's peanuts. We are talking about a one family house. I made some calculation on that. In, say, Germany, big country, made out of concrete. You always should do that, but that's another discussion. When you do, with a cost of 100 euros a ton, or say $120 a ton CO2, the cost for that single family house for only the concrete would increase with 500 euros, so $600. To be honest, for a single family house, that is not that much. It is important, we should not neglect it, but it's not the driver. or the hurdle that will prevent decarbonation. And I think that is the message that we have to keep in mind. We should leave the concept of only looking at emissions in clinker, European approach, or cement, which I see in other areas. We have to move into concrete, because that's the product that we have in the market and which people need. Thank you.
Okay.
Oh, thank you, Rob. Crystal clear. Maybe Claude, over to you.
Yeah, it seems we have lost Tongbo.
Yes.
That's unfortunate, but connection probably. Okay, we have
Hi,
now
Claude. I'm
discussed.
still here. Sorry.
Tongbo, great, you are still there. Do
Back,
you want
yeah.
to comment on the cost? Do you want to comment on the cost?
Oh, yes, I'd like to. Yes, based on our experience for the 50,000 tons, capacity capturing facilities, so we expect the direct operation cost is, something around $40 US. This is like something around 30%, lower than the post combustion. That's our estimation. That's one thing. The other thing is that my understanding at present about the viable solution, economically, so far with different type of solution, CCUS solutions, it seems that the mineralization sequestration process is more viable economically. And another solution, as I observe, is a CCS with EOR, which actually is through the increase of the oil production that can balance the higher cost at present. Thank you.
Thank you all. So we have discussed the capture, and you have all talked about all the nice projects that you have. We have talked a bit about the cost of the technology, the cost on the consumer. We have a lot of questions in the chat box about what do we do with that CO2 when it's captured. Well, we all know there are two options. Either it's kind of permanent storage, and I think that came out very clearly, Rob, from your slide. But then we have the big question of infrastructure for transport and storage. So it would be nice if you could, and I think that's a question to the three of you, elaborate on that. But then there is also a side question that mainly comes to Europe, but I believe that everyone could comment on it, which is how much do we think could go to utilization, and given the volume that we will capture with the cement industry, do we really believe that there is enough space for use, or how much percent? It was one of the question of what we capture we will be able to use, and how much percent will we be able to store. So Rob, maybe you want to start commenting, and then we can go the same way around. Rob, Jamie, and then Tongbo.
Yes, I'm happy to start with especially your last question. How much will go in utilization of the carbon that is captured in cement industry? Now, that's a big crystal ball question that I have no answer on, but I can guarantee you it will not be 100%. So we need carbon capture and storage as cement industry, and that is, thanks or due, whatever you call it, to the process emissions. Whatever you do with cement production, you always have these process emissions, and we can't escape from that. Use, I would say, 10–50% of the total volume of CO2 that is to be captured. That is not the total volume of reduction, of course, because we will do other measures as important, perhaps even more important. So 10–15% of CO2 that is being captured will have to be stored, will be used in products, and perhaps in earlier years more, because then the market will be developing, and in later years less. And for that, not only for carbon capture and storage, but also for carbon capture and use, but also for all these other things, so the use of renewable electricity, but also the mineralization, the recarbonation, we need real big infrastructural projects. We need pipelines for CO2. We need roads. We need a waste collection system. We need concrete waste collection systems so that we can use it in our plants again to mineralize it, to recarbonate it. So there is a lot of infrastructure to be done. And not only for us, that is the good point about it. It is also relevant for steel industry. That is also relevant for the chemical industry. Name it, they all will need this. So we are not alone. That's the good news. Thank you.
Yeah, big needs for infrastructure. Jamie, do you want to comment on both questions? You know, what's your feel about the balance between use and storage? And do you agree with Rob that anyway we need storage?
Well, I definitely agree with Rob, but I think that one thing that we should have confidence in is our ability to innovate as an industry, right? So I mentioned earlier Solidia. That is it's a cement, it's a special clinker that actually as we make it, it requires less energy and we reduce the amount of CO2 produced. So on a per ton basis, we produce less CO2 with it, and it also consumes CO2 in its curing process, right? So that's just one solution. And I believe as an industry, you know, we are intelligent people and we will be able to come up with more solutions like that where our process emissions actually decrease, right? And then we can find ways to utilize that CO2 in the curing process or for mineralization, making aggregates and returned concrete and such. So I have hope and I have confidence in this industry that we will continue to innovate and come up with solutions like that in parallel as we look at these other solutions, right? So, so yeah, I think infrastructure is key to all of this. The reason we chose our Portland, Colorado plant is because we're about 45 kilometers from a CO2 pipeline. It just happens to be there. So it's, you know, in order to do this at our other facilities, we will face challenges. So, you know, I think infrastructure is going to be a key part of it, and collaborating with other industries and in creating these so-called CO2 hubs, I think is going to be important as we move forward. Because I do believe it will, the mass amounts of CO2 that we produce currently, right? Knowing what we produce, and if we don't change our processes, it will be difficult to utilize all that CO2.
Thanks, Jamie. And Tongbo, mainly about use, because I have seen from your slide, and I knew it before, Sinoma is doing quite a lot of research into use and maybe also some different type of uses. Do you see a higher share for use in China than what Rob and Jamie were mentioning, or will it be the same?
And about the utilization of the CO2 capture.
Yes, kind of.
In China, actually, we prefer, you know, to use first, you know, the CO2, you know, we captured, to use it first. So now the capturing technology is already available, not just in China. It's already, you know, in the world. That's available. You know, the main challenge is the cost. Therefore, actually, if how much CO2 can be used, it's also you know, also depend on the cost of the CO2 captured. So my observation, as I mentioned, that through the mineralization sequestration process, as a kind of using, that's you know, that's some viable at you know, based on my observation and the calculation. And also we also, you know, expect to work with others in the sectors like the, you know, like the EOR just mentioned. I believe, you know, that kind of utilization, you know, can be, you know, can be viable, you know, economically also. Thank you, Claude.
Okay. I think, Jarat, it's time to already hand over to our MC. It's amazing how the debate. So
it is, and we've got
big thank you to our speakers. We will have a short concluding remark. Maybe Jarat, you want to also say a word?
No, just real quickly, again, thank you, Claude, to you for your leadership here, and to our speakers. We had hundreds of attendees and plenty of questions, and again, a fascinating conversation. So thank you all. But in the interest of time, I think back over to Kevin to close out our webinar here for today.
Yeah, I'll echo the same statement. This was a wonderful discussion. I'm sad to see it end so early. I'm sure we could go on for another hour if we wanted to, but in the interest of time, we'll just conclude here. If you'd like to learn more about the SIM CCUS initiative or the GCCA, please reach out via the various channels provided here. Also, to stay up to date on news and developments, follow both organizations on LinkedIn. And for those who might be furiously typing out these URLs, these are found pretty simply by a simple Google search, either SIM CCUS initiative or Global Cement and Concrete Association. So one final time, I'd like to extend a thank you to our panelists and to our attendees. We very much appreciate your time, and please enjoy the rest of your day. We hope to see you again at future events. This concludes our webinar. Thank you.